Hello. Probably when you first learned how to assign R and S for a chiral carbon, you learned on molecules or on drawings in which the lowest priority, priority number 4, is a dash, because the idea is to orient the molecule so you see a steering wheel, and a steering column would be priority number 4, and you could figure out whether priorities 1, 2, and 3 are going clockwise or counterclockwise. But what do you do if that lowest priority, priority number 4, is not a dash? What if it's a wedge? Or what if it's a line? And that is the thing we're going to look at in this video, how to solve those types of problems. Now, in the previous video, that video was what? It was 0 to F50. All of the examples that I went over had the hydrogen as a dash. And we had 3 other paths or 3 other groups. Now, the lowest priority isn't always necessarily hydrogen. What if your molecule has a chiral carbon that's not attached to any hydrogen? It just happened to be our lowest priority in all of those examples in this video right here. Okay. And we're not concerned about prioritizing. That was, again, in the previous video, using what? Using the Kahn-Ingold Prelog priority rules. In this video, we are concerned about quickly figuring out R and S from a whole bunch of different drawings that are not looking like this. Just as a reminder, what if arbitrarily this is priority number 1, priority number 2, priority number 3? When the lowest priority, 4, is already pointing away from you, meaning it is a dash, then all you have to do is read the drawing, and that's how you're going to designate R or S. This is clockwise, right? 1, 2, 3. Clockwise is R. Okay. I have a model here, and really it's oriented like this, where you have the hydrogen away from you. Okay, the red is wedge, the green is a line, and the blue is a line. Okay. The rule here, and I'll write this, the quote you want to memorize is, if 4 is on the dash bond, just read the drawing. There's no manipulation. There's no visualizing it in your head. There's no making a molecule and twisting it. Just read the molecule. And if 1, 2, 3 is clockwise, it's R. And if it's counterclockwise, it is S. Okay. What are some other examples? For the next example, we'll keep H, or let's not even call it H. Let's call it priority number 4. Let's point it away from us. Well, believe it or not, you could have a molecule that is situated like this. We have 2 wedges. That's strange. And we have 2 dashes. Okay. And again, I'm going to make one of the dash lines priority number 4, and it doesn't matter which side. Because, again, if priority number 4 is dash, just read the molecule. Now, let me prove to you that we can have 2 wedges and 2 dashes. By taking the same molecule that we use for this drawing, what if I orient the molecule like that? Do you see how the hydrogen on the left is pointing away from you? But look at the green atom that I'm holding. That's also pointing away from you. The red and the blue are pointed towards you. So you can have a molecule oriented where you have 2 wedges and 2 dashes. This rule still applies. If we arbitrarily put 1, 2, and 3, just read the molecule because priority number 4 is a dash. And we have 1, 2, 3. That is counterclockwise. Okay, double check my work. Counterclockwise, sinister, S. What's one more way that we could see a chiral carbon with dashes and wedges? We could see the chiral carbon like this. What about that? Okay, and again, let's make the dash priority number 4. and arbitrarily, randomly put 1, 2, and 3 somewhere on the 3 bonds. And again, priority number 4 is a dash. Just read the molecule. 1, 2, 3. That is clockwise. Right? Yeah, it's clockwise. And this is R. In all 3 cases, priority number 4 is a dash. And again, you should be able to take a tetrahedral carbon molecule and model and orient it so you can match one of these drawings. Okay. Now, the purpose of this video, again, is determining R and S when the lowest priority is not dashed. Okay. So there's our first rule or trick. What if it's wedge? Let us take this standard drawing of a tetrahedral carbon and purposely make priority number 4 wedge. Okay. Again, if you're still a little bit unsteady about how to prioritize, if these were real groups, like a hydroxyl group or a methyl or a fluoro, then look at the previous video to learn the Kahn-Ingold-Prelog rules for prioritizing. But ultimately, once you know how to prioritize, you can always redraw the molecule and label your 1, 2, and 3. So this is different. We have priority number 4 as a wedge. I have another phrase for that will help us. If 4 is wedge, what do you do? If 4 is wedge, this is what I like to say. I tell myself it looks blank, but it's actually blank. You take the opposite. Because since priority number 4 is pointing towards us, we are on the wrong side of the steering wheel. We're on the hood, basically. Right? We need to be in the driver's seat. So from the driver's seat, they see a different orientation of 1, 2, and 3 than we do looking through the windshield. Okay? So basically, we have a model that 4 is towards you. Okay? But we really want to orient the molecule. Okay, so hydrogen is towards us. You really want to orient the molecule so the hydrogen is away from us on the other side of the windshield. But without using a model, all you have to do is read the molecule and take the opposite. So this is 1, 2, 3. It looks counterclockwise. It looks S, but it's actually R. I guarantee you, if you take your model and you label these atoms 1, 2, and 3, okay, from our point of view, when the hydrogen is like this, it will look S, okay? But when you turn it around, you'll notice that it is R, okay? Let's not worry about the models, okay? If you need to verify this, then yes, go ahead and use the models and label the pieces 1, 2, and 3, okay? Again, take the opposite if it is wedge. Therefore, if we have this drawing, I like to call this like the bow tie drawing. But what if the bow tie, we have the wedges on this horizontal line? Okay. You might know this as a Fischer projection, or the Fischer projection, like this. I'm going to make priority 4 on this bond here. But you understand that the Fischer projection is the same as having the 2 wedges on the horizontal line. This is a Fischer. We're not going to go too in depth with this. I'm trying to figure out how to spell Emil, E-M-I-L. I think there's a C in there. Fischer projection. And this is, we'll call this hugs. The Fischer projection is giving you a hug, okay? The 2 wedges holding their arms towards you. Anyway, 1, 2, 3, 2, 3. Lowest priority is 4. Well, duh. Lowest priority is wedge, and it looks. What does it look like? It looks counterclockwise, S, but it's actually R. So this one's R also. This is R. Okay. Honestly, if you're super good at visualizing, since both of these molecules are R, you can take this molecule and rotate it in your mind to make it look like this. Okay. Honestly, under stress and under pressure, I can't do that. Okay, I can't do that. You can always take a model and assign 1, 2, and 3 for your colored pieces. But let me double check that actually. Let me see if I can do it in my head. That's wedge. Interesting. Give me 1 second. Oh, there. Okay, there's 3. Okay, I got it. See, what I'm doing is it's hard to explain actually. If I lie down here and my eyeball's looking this way, I could get 4 and 3 to look horizontal, and then 1 would be at the bottom. Again, a skill that you don't need to know how to do. Just do this trick. Take the opposite. Okay. By the way, I wanted to look at a molecule on the cover slide, and let's assign R and S. Let's assign R and S for that carvone, I think is the one on the right, and spearmint. Okay, they are enantiomers. They are mirror images, just like my hands, but they are different. They are not superimposable. So let us take this one, the spearmint, and let's assign R and S. R and S. This one is, after you have the priorities, it's relatively easy because the hydrogen on the chiral carbon is dash. So give me 1 second while I copy this. Yeah, might as well review our priority rules using this molecule here. And I have this drawing right there, spearmint. And after the video, you could do carvone and make sure that they are different. They have different RS designations. Okay, here is my dash. There's my hydrogen, implied hydrogen, and that's priority number 4, obviously. Okay, in the previous video, I said have stick figures walk away from the chiral carbon, and they all happen to end up on a carbon. Okay, green, red, and purple. Then you play cards. Do you remember how to play cards? Let's do this double bond first. That person is standing on the carbon, and they are doubly connected to this carbon on the left, and singly bonded to the carbon on the right. So their cards are CCC. This one right here, see, we're going to have a tie, because this is a CH2 group, and this is a CH2 group. Oh, actually, before we take care of the tie, this one is the winner between green and red and purple because they play a C and then a C and a C. Their second card is C. Their second card, I might as well write this, CHH. Do you remember how to play cards from that previous video? So we have a winner right here. No, right there. The second card, C beats H beats H. Priority number 3 is going down, the wedge. Okay. But we have tie, CHH, CHH, and remember I said to make them keep walking? This is going to be a good battle right there, because we have the green person on that dot, and we have the red person on this dot. Why don't you write the cards? I'll wait for you. Okay, this red stick figure is attached to a carbon doubly, and is attached, to a hydrogen. This carbon is doubly attached to oxygen and then attached to a carbon. We have a winner between red and green. The green is the winner between red and green. So this is 2. Oh my goodness, why did I put 3 there? No one stopped me. This is 1. This is the highest priority. I don't want to redo this video. We have priority number 1, purple. Between red and green, green wins because of the O. So that's priority number 2. Priority number 3 is this path over here. Okay, I know it's a little bit crowded. 1, 2, 3. 1, 2, 3. 1, 2, 3. Clockwise. Spearmint is R. Spearmint is R. 1. So down, left, right. Down, left, right. Clockwise. Let's take a look at Carvone, the natural oil or molecule of caraway seeds. And priority number one is down here, 1. Priority number 2 is here, 2, 3. 1, 2, 3. Counterclockwise, Carvone is S. You could look it up yourself on Google. Spearmint should be R, Carvone should be S. Now I've stalled quite enough because I think you understand what is the hardest molecule to assign R and S. We have a trick. It's not really a trick. When it's dash, you just read the molecule. When 4 is dash. When 4 is wedge, you take the opposite. So now we're left with if priority number 4 is a line, And I'm going to use a new piece of paper for this. Okay. Let us try something. Let's try one that might be easy for us to visualize. Okay. So if priority number 4 is a line, 4 is right here. Okay. Or it could be the line up here, but I'm going to leave it here. I'm going to show you maybe 2, possibly 3 ways to do this without a model. Let's make priority 1 the dash, priority number 2 the line going up, priority number 3 here. Now, yes, for some molecules where the lowest priority is a line, you can go back and just read the molecule, or you could take the opposite. But if you get it right, that's just a coincidence, okay? Do not use these rules when assigning a molecule where the lowest priority is a line, okay? So we have dash, we have wedge, and we have line. So there are a couple things. If 4 is line, first thing that I would do is try to pretend you are a stick figure driver. I want you to sit in the driver's seat. There's priority number 4. So the driver's seat is right here. See, that's the steering wheel. And the steering wheel is 1 to 2 to 3. Can you tell where is priority number 1 in relationship to the driver? From our point of view, 1 is going away from us, but we're outside the car looking at the car, looking at his, I guess this would be his left side, right? His left side is closest to the window. But forget about that. Put yourself in the driver's seat. Where is 1 from their point of view? I think 1 is, so here's the steering wheel. Okay. I think priority number 1 is, ooh, I almost did it wrong, to the right. Okay, what you can almost do is you could take your paper and you could tilt it like this so priority number 4, the line is pointing away from you. That dash is to our right now, okay? Or plainly, the dash is to the driver's right. Where's number 2? The 2 is at the 12 o'clock position. I think that's pretty obvious that the driver's 12 o'clock position is 2. And then 3 has to be here. 1, 2, 3. By doing this, okay, pretending that you're the driver, you have a steering wheel, and 1, 2, and 3 is this, in this example, counterclockwise, S. Okay, is that hard? It's a little hard. How about this one? If we have, we're going to do the same trick. We're going to orient ourselves. But let's do this a little bit harder. Let's make priority number 4 way up here. Okay, and let's put 1 here, 2 on the wedge, 3 over here. Well, if you're the driver and you need a steering wheel, you can either look like this. Oh boy, that's horrific. Like that. Okay, and the point of view is going up. Or you could even say that the person's lying down, but all you have to do is, if you rotate it like this, see there's the driver, okay? But let's not rotate it. Let's try to do this lying down. From that person's point of view, do you realize that their steering wheel now looks like this? Because, see, 3 is at their feet, going down. 1 is what? Where do you think 1 is? 3 is here already. Where do you think 1? Do you think 1 is to their right or to their left? Okay. 1 is to their right, almost upper right. And 2 is to their upper left. Okay, so see 1 and 2 are above the driver's head. But see that 1 is in the, when you're driving with your hands, the 2 o'clock position, the 10 o'clock position. 2 and 10. Again, by using this stick figure and pretending you are the driver, you can, most of you can visualize the steering wheel. 1, 2, 3, S again. Okay. Now, I want to give you another way. And we're going to verify that this other way gives us the same answer. So we're going to assign, again, priority number 4 on top, the same molecule as this one over here. 1, 2, 3. The other way is to realize if you switch to, we'll call them groups, 2 groups, you just made the opposite stereochemistry. I don't like doing it this way because it requires to redraw the molecule, and every time I redraw a molecule, I'm always afraid that I'll redraw it incorrectly with the wrong stereochemistry. But let me show you this trick real quick. If you switch 2 groups, you made the enantiomer, or you could say the opposite stereochemistry. Why would I want to switch 2 groups? Because if I switch 1 and 4, I could get 4 to be dash. So this is the redraw. Okay. You can already tell, I hope, that this is longer. But if you don't like being in the driver's seat and trying that visualization trick, then switch 2 groups. Okay, redraw, switch 2. You want to switch 4 and 1 to get 4 on the dash. So that is your switch, 4 and 1. We have a 2 still on wedge and 3 here. You don't switch the other 2. When you assign this, okay, 4 is dash already. When you assign this, this looks R, because it goes from 1 to 2 to 3. But you gotta remember that you made the opposite. So it's not actually R, it's actually the original drawing, this drawing right here. the original is S. And we had established that it's S from our trick over here when we were the driver of the car and we see the steering wheel. Okay. Again, if priority of 4 is the line, you could do two things. Either you can pretend you are the driver and literally draw your stick figure, or if you don't like that, which I hope most of you do like it, because you could do it this way by switching two groups and redrawing it. I just worry that you're giving yourself a chance to make a mistake by redrawing it. But when you switch two groups, you make the opposite. So you could almost say that, well, not almost, but if you switch four groups, if you switch 1 and 4 and 2 and 3, and then read the molecule, you will have the actual stereo count, so you will get S. But I only did one switch here, right? I only did one switch here. Okay, practice, practice, practice. I think I'm going to put up one more video with assigning R and S, and it's going to be tricky because I'm going to show you how I would assign R and S for molecules that are drawn as chair conformations and Newman conformations or Newman projections. Okay, all of these are just a normal standard tetrahedral shape. Okay, but next video we'll do something a little more complicated and assign R and S for complicated molecules.